Hello everyone, welcome back to Diksha Vedantu Foundation YouTube channel, and today is Saturday, so time for revision. So what we will revise whatever we have studied throughout the week, right? So we will revise the magnetic effects of electric current chapter, and tomorrow based on this chapter there will be a mock test. So if you are interested in the mock test, you can click on the link below and join our WhatsApp channel. We will be sharing the question paper in our WhatsApp channel. So let's start with the chapter in a glance, that is the mind map. So magnetic effect is the chapter's name. So magnetic effect can be due to magnetic field and field lines, and then current carrying conductor, then we have straight wire, then we have circular loop, then we have solenoid, then we have right hand thumb rule, and lastly we have a force on a current carrying conductor and a left hand rule of Fleming's left hand rule, right? So these are the main concepts of the chapter. We have already completed everything, so we will just do a quick revision of this chapter without wasting any time. I will not go into the detail of everything again because I have already, as I said, completed the chapter. So this is only for your revision. So how you can revise the chapter quickly just before exam, if you are watching this video, definitely it will help you to revise the chapter quickly. Now so let's start with magnetic effects. An electric current carrying wire behaves like a magnet. So we have learned that if there is a current in a conductor, that conductor behaves like a magnet, right? The region surrounding a magnet in which the force of the magnet can be detected is said to have a magnetic field. So this is also important concept of what is a magnetic field. Magnetic field is the region of influence of a magnet. Now since a current carrying wire also behaves like a magnet, so they also have a magnetic field of their own, right? So that's why the magnet and magnetic magnet due to electricity both are somewhat linked, okay? Even though the magnet can exist individually, but electromagnets or magnets which are being produced using electric current, they cannot exist without the electric current. If you stop the electric current, there will be no magnetic field, but still if the current is flowing in the circuit, there will be a magnetic field associated with the current, right? The magnetic field is a quantity that has both direction as magnitude. So magnetic field is a vector quantity. If you remember, vector is something which has a magnitude as well as direction, whereas scalar is something which only has a magnitude only, no direction. If you know any other example of vector and scalar, don't forget to mention that in the comment below. Now let's move on. The field lines of a magnetic field around a straight conducting wire are concentric circles. So if you are considering a straight wire, okay, as I said, any conductor which is carrying current will definitely have a magnetic field, and the field lines is the representation of that magnetic field and how they are oriented, right? So magnetic field due to a straight wire is a concentric circle, and to find that we have to point our fingers in the direction of current and then rotate our fingers. So whatever is the direction of our other fingers, that is the direction of magnetic field. That is the right hand thumb rule, if you remember, right? Here we have an example of a practical example where a copper wire carrying current, and there we have some iron filings which after tapping they organized in a perfect circle, right? So if you know the direction of current, now in this diagram you cannot determine the direction of the magnetic field unless you know the direction of current. In case the current is flowing in the upward direction, then field lines are in this direction, but if it is in the downward direction, then the field lines in the opposite direction. Both cases it will be circle, but based on the direction of current you can determine what is the direction of magnetic field lines. The magnetic field produced by a current carrying straight wire depends inversely on the distance from it. So this is also very important. As you are moving away from the conducting wire, okay, the magnetic field strength decreases inversely with the distance. There was a question in the previous year section. If you have watched my PYQ section, there was a question, how does magnetic field strength changes as you are moving away from the conducting wire. So as you are moving away from the conducting wire, it decreases inversely with the distance, right? Now right hand thumb rule, I already explained it. Imagine that you are holding a current carrying straight conductor in your right hand such that the thumb point towards the direction of current. then your fingers will wrap around the conductor in the direction of the field lines of the magnetic fields. Okay, so if you point your fingers in the direction of the current, okay, then and wrap around your fingers in the direction, then it will give you the direction of magnetic field lines. Okay, direction of magnetic field in that region. Okay, so this is the magnetic field, it is circular. So if you have to wrap your hand in the direction of current, thumb, point your thumb in the direction of current, and then wrap your fingers around the conductor, then your fingers will point the direction of magnetic field. It's very useful, not only in class 10th exam where you have to write this rule, also as you move forward, if you study science in class 12th, then this is a very important law to remember, because based on this law there will be some conceptual question. Now let's move on to the next concept, that is magnetic field due to a circular loop. So as you know, in the circular loop, if it is carrying a current, okay, all the lines magnetic, you can consider for when it is very far from the center, you can consider them to be a straight current carrying conductor, and near the edges of the circle you will find the circular magnetic field lines, and slowly the circle radius of the circle will become bigger and bigger, and at the center the magnetic field will be constant, it will be a straight line. So by making a circular coil, you can make a constant magnetic field, and magnetic field lines never intersect. So there was a question in your previous year question paper where they have given you some lines where they are actually intersecting at this straight line, which is not possible. They will not be intersecting each other in any circumstances. So that's why there will be no intersection. So you have to identify this is the correct diagram, right? Now let's move on. This is solenoid, a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. So if you take a cylindrical coil, okay, last time you have seen only a single circular coil, now you have made it in a form of a cylinder. So basically what you have done, you have taken a cylindrical empty box, okay, there are different rolls available, right? If you ask your mother, there may be a kitchen roll available, empty kitchen roll casing that can be used as a solenoid. If you wrap some copper wire, insulated copper wire, remember that, not any other copper wire, insulated copper wire, which is a very important thing. If you wrap it around that cylindrical casing, then you will get a solenoid. Okay, solenoid preparation is pretty easy, and when you connect it to a battery, okay, the current will flow in that circuit and it will produce a magnetic field, and it will behave as if it is a bar magnet. Normally it will not attract anything, but if you put something in the core, this is called the core, the inside of a solenoid is called a core, and if you put something inside it, okay, then what will happen if you put something inside this region, okay, suppose a soft iron core, okay, if you put a soft iron core inside this, okay, what will happen is that it will behave as a magnet, and thus iron will behave as a magnet. This combination is called electromagnet. Okay, this is called electromagnet, and once you switch it off, the magnetic power will be gone. So that's why it is called electromagnet. It works on the principle of electricity. If there is no electricity, it will no longer be a magnet. There are certain materials which can be turned into permanent magnet if you put it inside the core of a solenoid, but we do not use those materials for purpose of electromagnet. Electromagnet has a wide range of applications, okay, mainly industrial application. Okay, if you want to lift some heavy object, heavy magnetic object, for example iron, if you want to remove some iron object from one place to another, electromagnets are best. Similarly, if you want to separate say iron from other metals, okay, other metals are non-magnetic, only iron is magnetic, okay, iron, cobalt and nickel, these are the three objects which are magnetic. So if you want to separate any of these three materials, you can switch on the magnetic field. As soon as the magnetic field is switched on, okay, the magnetic substances get separated and non non-magnetic substances remain. So that's how you can separate. So magnetic separation is one of the way. Similarly, if there is an iron object falls into your eyes, okay, you can remove it using iron electromagnet. And one more very important medical application is MRI devices. Okay, MRI, magnetic resonance image, which actually uses electromagnetic concept of electromagnets inside that. It's a huge, very strong, powerful magnet, okay, that is used to image our inside. Okay, some part of our inside of are magnetic, so you can use that concept to image our in body parts, right? So that is the one of the application of electromagnets. So electromagnets are one of the most widely used application of this chapter. Now, what else? Force on a current carrying conductor. So similarly, we have seen that that when the current is flowing through a conductor, it behaves like a magnet, right? Similarly, if you put that current carrying wire already under a magnetic field, that is, if you put that current carrying wire with the help of a magnet, okay, what will happen? This magnetic field, the already existing magnetic field, and the magnetic field produced by the current carrying wire, they will interact. Okay, we know that like pole repels, unlike pole attracts. Similarly, based on the poles that is generated here, they will either get repelled or they will get attracted, right? Based on the direction of current, based on the magnitude of current, how far it will be attracted or how far it will be repelled. So that will depend on the magnitude of current, and whether it will be attracted or repelled, that is only dependent on the direction of current. Okay, that can be determined using right hand thumb rule. You can find the polarity of the magnet, but that is not part of our syllabus, so I am not going to discuss that. But an electric current flowing through a conductor produces a magnetic field. The field is so produced, it exerts force on a magnet placed in the vicinity of the conductor. So basically, two magnetic fields, they interact with each other. Right, two magnetic fields, they interact with each other, so they either repel, they either attract. So there is a force acting between a current carrying conductor and a magnetic field. And to find the direction of force in the conductor, we do not need exactly the direction of magnetic field, we just need a law. The law that we are going to discuss is the Fleming's left hand rule. Very, very important for exam. Almost every other year they ask state and explain Fleming's left hand rule. Sometimes they will mask the question that one magnetic field is present and magnet is present in a current carrying conductor, it is exerting a force. Which law will be used to explain the direction of force? Which law you will use to find the direction of the force? So that is also important tactics that sometimes in a case study based question they will mix it. They will not ask the question directly that this is Fleming's left hand rule. So first you have to identify, okay, Fleming's left hand rule I have to apply, and then using that rule you can find the direction of magnetic field. Now what is Fleming's left hand rule? According to the rules, now this is on for your left hand. So first law, thumb rule, is for your right hand. So to apply thumb rule, you have to use your right hand. To apply Fleming's left hand rule, as the name suggests, you have to use your left hand. Okay, according to this rule, stretch the thumb, forefinger and the middle finger of your left hand such that they are mutually perpendicular to each other. Okay, and I have seen students, they often confuse about how to draw this diagram. So what you can do, you can simply use this arrow diagram. That is fine. Okay, arrow diagram is fine if you remember how to apply the arrow diagram. So this will be your you can use another arrow diagram. I will show you that. So basically this is your forefinger, this is your middle finger, they are perpendicular, and this is the thumb. So this is the force. Okay, now what is that? If the first finger points in the direction of magnetic field, so the first finger is magnetic field. Okay, and the second finger in the direction of current. So this is your direction of current. So first finger is this, first finger points in the direction of magnetic field, second finger points in the direction of current. Then your thumb will give the force acting on the conductor. Okay, so then the thumb will point in the direction of motion of the force acting on the conductor. This is one other way to represent the Fleming's left hand rule. You don't need to draw the hand and explain like this. If you want to draw a diagram, better to draw the arrow diagram. This is much simpler, this is much easier. Okay, so that's why if you are attending the revision class, it will also add some information to you. I have not discussed that during my regular class. So if you have attended the regular class as well as if you are attending the this class, don't forget to mention that in the comment below. Now, if you are in our country, the potential is 220 volt 50 hertz. So the country, in our country, the power supply that we use is 220 volt 50 hertz. So it is an AC current. What is an AC current? AC current is something which fluctuates with time, right? So AC current is which changes with time, and DC current is basically which is constant. DC current is constant, it's flat. That DC current we generally use to run our mobile phone, to run our laptop. Okay, the battery that is used, okay, that is DC current source. Even mobile remote, okay, any toy car, wherever you see a battery is used, that is a DC current. Whenever you plug in to the main power supply, they uses AC current. For example, AC current is used by the fan, used by the light, used by the refrigerator. There are a lot of devices which uses AC current. There are some devices which convert AC to DC and then utilize it. For one example is modern televisions, not the older generation CRT monitors, but modern televisions, they first convert AC to DC, because the electronics inside the TVs, they are not compatible with AC current. They can only use direct current. Okay, so they have some mechanism inside which can rectify the AC to DC, and then it is used inside the AC. So basically AC is the source that is used for all the cases, because AC can be converted into DC very easily. On the other hand, DC is very difficult to be converted into AC. AC is easy to convert into DC, but DC is not easy to be converted into AC. Okay, so that is why DC has limited applications. Okay, even the mobile phone charger that you are using to charge your mobile phone, that charger is converting AC to DC first. Then that DC is used to charge your mobile phone, and then you are using that mobile phone. Right? Similarly, the laptop charger also converts AC to DC, and then it charges your laptop, because all the electronics devices, they require DC to function. All the non-electronics devices, they can function easily using AC current. Okay, clear? Now the earth wire, which has the insulation of green color, is usually connected to the metal plate deep in the earth near the house. So generally, if you have seen, there are three colored wire. Okay, one is called live wire. Live wire is where the current is main current is coming through. Okay, there is a neutral wire. Neutral wire is required to create a potential difference. Neutral wire means zero potential. Okay, it basically takes the current through it. Okay, when it is not connected, it has no power supply through it. And there is a ground connection. Ground connection is something which is an extra. Okay, that is decided by your local environment. The power supply that comes from the supply commission, they have only two wires, live wire and neutral wire. The ground wire is done in your own home. So check your own home if you have a ground connection in your home or not. Tell me in the comment below. Okay, electric fuse, an important component of all domestic circuits. So electric fuse is something which is used to protect the electrical devices. So when the current in the circuit becomes high due to any reason, n number of reasons there can be possible, due to which when the circuit is getting, we say this is getting overloaded. When the circuit is getting overloaded, there is a high chance that the device which is using that, they might get burned. So that's why there is a safety mechanism which is called fuse. Fuse is a safety mechanism which burns itself out to protect your costly devices. The cost of fuse is very small, okay. So by burning the fuse, your costly lakh rupees of devices getting saved, which is better, right? Instead of purchasing the entire laptop or entire TV, you will better like to go and buy a 10 rupees fuse, right? So that is easy. So fuse is a easier way to stop this prevention. And nowadays I also mentioned another device name. If you have attended my lectures, I gave you modern equivalent of fuse. Fuse is no longer used in our day-to-day life. Another device which is used, if you know the name, don't forget to mention that in the comment below as well. Also, if you are still confusing about your future, and if you are not able to decide what to do in future, what should be my future, you are completely hopeless, your parents are saying you are worthless or worthless, whatever it is. So what you should do? So you should attempt one of our very interesting project, Diksha Scholastic Aptitude Test or DSAT. Okay, this will give you a clarity about your capabilities. Maybe you are not sure about your capabilities, so that Diksha Scholastic Aptitude Test will give you a clear clarity about your future. Okay, what you have to do? You have to fill up this form. Our representative will contact you, and what you will get in DSAT? You will get a complete 60-minute concept-based lecture and a doubt clearing session. So based on that lecture and doubt clearing session, there will be a aptitude test. Once the aptitude test is over, based on the test result, a one-on-one counselor will help you to guide through your future. Okay, if you are, maybe you are not sure what to do, but actually it turns out to be you will be a good candidate if you appear for NEET exam, which is for to become a doctor. So you have a good doctor material within you, but you don't know. Or you want to be, you can be a top engineer of India. So that's how you can try this test. That will show you what is your capabilities, what is your limit. So don't restrict yourself, don't let others judge you, do a scientific method to judge your future, right? So I will be back with the mock test solution tomorrow. Till then, bye.